Hi, welcome to our webinar. I'm Paul Morin with the Energy Conservatory, and this is the fourth of a four-part TECLOG software series. This is an advanced TECLOG3 series titled Testing Non-Residential Buildings. If you're having trouble with your audio, go to the meeting pull-down menu and go through step by step the audio setup wizard, and that should take care of that audio problem. And feel free to type in questions as you think of them, and we'll be answering some questions as we go along. And then at the end, we'll also be taking questions. Because this is a pre-recorded session, you may be streaming audio at different rates than others, so we will have about a 5-minute delay at the end. Some of you may see a delay at the end before we start taking questions. During that time, feel free to read through the questions and answers that are already there, and then we'll take time to answer some more questions at the end. And as always, there'll be a link to the webinars on our website, and that'll take you to our YouTube site where you can view all of our previous pre-recorded webinars and training videos. And we're always looking for ideas on new webinars for the future, so feel free to email us or call us and give us tips on what you'd like to see for future webinars. So first part, we're gonna go through setting up a 3-fan blower door system. It is similar to 1-fan system, but there are a lot of differences. So we'll go over those differences on how to set up a system. We'll review a completed TECLOG3 test that was done a while ago on a 10-story building with 4 fans. It's a pretty tight building. We used 4 fans, and we had 9 DG700s. We were monitoring interior pressures and exterior pressures at the top and bottom of the building. It was part of some research we were doing, and we'll go over what that test looks like and the power of the software on how much data you're able to collect and how it's displayed and what reports can be generated from it. Then we'll configure and run a new TECLOG3 test. It's a fairly simple test. We don't want to take a lot of time showing you we just want to give you a basic idea on how to set up a test and what's different on a commercial building test than a regular building. And then we'll look at breaking out single zone results from multi-point test. A lot of times when you're testing a commercial building, there'll be spaces that aren't intentionally connected to others. There's no door from the main body of the building into other zones. You have to enter them from the outside. Some examples of that might be an electrical or a mechanical room, or maybe you're testing a strip mall or something like that where there's no doors between the units, and you want to know the tightness of each individual zone. There's a way to do that with some additional steps, and we'll talk about that. So setting up a 3-fan blower door test. E779 ASTM E779 requires pressurization and depressurization tests, and the Army Corps follows a version of that, the Army Corps protocol, for all new military buildings being built. And so we'll show setting up the blower door for pressurization and depressurization, and some options on how to connect that to a computer. So we do have red nylon panels with 1, 2, and 3 holes, and you may be using some combination of those on the building, especially if you have separate zones separate zones that where you have bottlenecks or multiple floors. If there's enough stairways, then you don't have to worry about setting up fans on each floor. So we'll show the setup of a 3-fan system. First step is you put in the lower fan, and then the middle fan, and the top fan. So we've got the three fans installed, and we'll use two DG700s for a 3-fan system. And then we added the three speed controllers, the bottom controller for the bottom fan, middle controller, middle fan, top controller, top fan. Instead of using flow rings typically in a test, we'll use open fan, and as fan pressures get low, we'll click one off. So it's very helpful if if the top controller goes to the top fan, if it's the top fan you want to turn off, because the software needs to keep track of that, which it needs to know which one you turned off. So that's a pretty simple way to allow you to do that. And then the first tubing will connect, the gauge on the left, channel A, will run a green tubing to the, it's kind of hard to see here, but there's a patch with a tap on it to connect your tubing to, and you'll connect that green tubing to that tap. It's a double-sided tap. You can see there's a blue one up here, there's a green one at the bottom, and you'll connect the tubing to that. And then on the outside, you'll connect a long tube to that and run it. Typically you'll run it to the center of that side of the building. And then the second tube, channel B, will connect to the lower fan. So this is a setup for single fan system. This is how you're always setting up. And then for the second gauge, the gauge on the right, we'll run a tube from input on channel A to the second fan, and then we'll run a tube from input on channel B up to the third fan. Because we've got three fans here, we're going to have, when these are all running, we're going to have a lot of turbulence in this area. So we've got 4 open taps now. The 3 reference pressures and the input for the envelope pressure are all open taps, and they'll see a lot of turbulence and airflow in that space. So we want to connect tubes to those and get them out of the turbulence of the fan. So we'll connect them, and with a 3-fan system, you get a tubing kit that includes all of these proper lengths of tubing for this connection. And so we're going to tee together some connections here to connect the 4 fan references to the blue tube, and we'll run that off to the side. It's got about 12 feet of tubing that allows you to get that out of the turbulent area. And then on channel B input, we'll do a separate white tubing. And the reason we have those separated is when we spin the fans around for the pressurization test, we'll want to be, our fan references will be measuring fan pressure with reference to the outside instead of fan pressure with reference to the inside, because instead of the flow sensor being inside, the flow sensor will be outside. So the next step is we will add our fan control cable, and there's a 3.5mm tap on the top of the gauge that you'll plug the fan control cable into, and each gauge with the master controller in the software, each gauge can control up to 6 fans with that fan controller. Typically you'll use it to control 3 for a 3-fan system. So you'll plug in that tap into one of the gauges, and you could plug it into either gauge, but we're plugging it into this because the speed controllers are right below it on that side, and it'll split that into 3 separate signals. And then we've got 4 feet of 3 cables that are shrink wrapped together to make it easy to connect them, so that will plug in and then connect to the taps on the side of the 3 speed controllers. Next, we've got a couple options on connecting to the computer. What we're showing here is on the top of each gauge, the gauges have a 9-pin serial connection on the top, and we'll go from we'll screw these adapters on the top that go from serial to Cat5, and Cat5 is regular Ethernet cable that's pretty inexpensive and readily available. And and then we'll use a splitter to combine the signal of 2 gauges onto one cable. So then you can run one cable back to the control center where you're controlling all of the fans. So, and that cable might be 100 feet long, it might be 300 feet long. We've successfully used up to 3,000 feet of cable with the serial connection. That's one nice thing about a serial connection is you're virtually unlimited on how long that cable can be. So, and then we have to split that back out into 2 before we plug it into a hub. And these hubs are available in either 2-port, 4-port, 8-port, 16-port hubs that are serial to USB. So this one is an 8-port hub, so you can plug 8 gauges into this hub, and then that information goes over one serial port into your computer. And the other option is going wireless. If you have a Wi-Fi adapter for each gauge, you put those Wi-Fi links into router mode, connect them all to a router, and because your computer can only connect to one Wi-Fi connection, you connect to the router either by cable or by Wi-Fi. Make the connection between the router and your computer. The next step is for pressurization testing. We'll need to spin the fans around. So we'll turn the first fan around, second fan, third fan. Now our rings are on the outside. And typically we won't use rings for a big building test. If our fan pressure gets low, we'll just turn one fan off rather than putting rings on. So in most cases on bigger building tests, unless you've got a fan in a small zone where you're trying to control the pressure in that zone, we won't use rings. We'll just use we'll use fan caps to cap over the fans. And then we'll take that blue tubing that was off to the side and we'll connect that to that blue tap. So now we're measuring the outside pressure with the three fan references. Next step is we'll review a completed TECLOG test, and this is a test that we did a while ago on a 10-story building, and we used 4 fans for that test and 9 gauges. Because we're doing research on this, we were measuring pressures on 4 sides of the top of the building and 4 sides of the bottom of the building. And we were monitoring some interior pressures. We set up all the fans on the ground level from the front of the building, and we're monitoring pressures on the 10th floor with respect to that space. And there are some other pressures in that building that we were monitoring also during the test. So we'll take a look at that test. We'll talk about what's required in the U.S. Army Corps of Engineer test. And we'll look at advantages of measuring pressure on 4 sides of the building. So we'll look at that, at the results of that test, and show why there are definitely advantages to measuring on 4 sides of the building. And we'll look at that top floor with reference to the floor the fans were on to see how those pressures were affected. And we'll review the test results, and then we'll review the U.S. Army Corps of Engineer report you can generate with all of the data required by that protocol. So in the U.S. Army Corps test, it requires you to have 12 baseline readings of at least 10 seconds each, and the reason I'm going over this is because it's important you know what data needs to be included in the test, because TECLOG3 is not a fully automated test. You'll have to decide which pressure points you're going to take data at, and you'll be creating what are referred to as periods of record during those so you choose which data is going to be included in the results, and so we'll go over that so you'll know which data points you'll need and what time period. If you choose Army Corps test in the software, it'll choose some default baseline periods of record and default fan on periods of record, but those are adjustable. So if you're testing to other standards that have different requirements, you can adjust those. So it'll take 12 baseline readings. It requires 12 baseline readings of at least 10 seconds each, and we do that by taking a 120-second baseline period of record, and then in the report it's broken out as 12 readings of 10 seconds each. And you need a pre-test and post-test, and you need to do a pressurization and a depressurization test. So if you're doing depressurization test first, you'll do a pre-test baseline and a post-test baseline for depressurization, and then you'll do a pre-test baseline, post-test baseline for pressurization. And when you do 2 baselines in a row in the middle there, it'll assume you're going from test 1 to test 2 at that point, and it'll label them as such, and it'll move you from one test to the next when you do 2 baselines in a row like that. And then you'll need to take 10 data points at positive, 10 at negative, and typically they're from about 20 pascals up to 75 pascals, 5 pascals apart, and you want them to be equally spaced. They need to be averaged be an average of at least 10 seconds. The default is 20 seconds for in our software. The highest data point must be at least 75 pascals induced. On that test we did, 10-story building with about 30 degrees outside, we had about a negative 20 baseline. And if you want an induced pressure during a depressurization test, you'll need to go to negative 95 to get a change of 75. So the software will cue you after the baseline how much you need to adjust your target number forward to get an induced pressure of 75. It'll tell you how much you'll need to adjust it by. So it prompts you to make that change after the baseline period of record. It's a good idea to maybe shoot as 80 pascals for your first induced pressure to make sure you end up with at least 75, because it's going to average the pre-test and post-test baseline. And if that post baseline is a higher number, then you need a higher induced pressure. So just to be safe, it's a good idea to jump up to 80 pascals as your highest point. And it does have a requirement that the baseline be less than or equal to 30% of the lowest induced pressure. So in the case of our test, we had a negative 20 for a baseline, which means we need to be at about negative 60 for our minimum data point. So we'd be gathering data from 60 pascals to 80 pascals in evenly spaced periods in that case. So we'd meet this standard. It's less restrictive than ASTM E779, which has restrictions on temperature difference and height of the building and wind speed. This allows you to test under a lot more weather conditions than if you were strictly following ASTM E779. And the pressures within the building must be within 10% of the envelope pressure. So software allows you to label interior pressures that you're monitoring as interior pressures, and then it'll compare those pressures with the envelope pressure in the report and show you whether or not they're within 10% of the baseline. So that's one nice thing about being able to see a graph and seeing your data as you're going along, is you can see right away if you're within 10% And if you're not, you need to put a fan in that restricted zone. Okay, so next we'll open the file and take a look at it. So I've opened the completed TECLOG file, and so this is a file where we have 4 baseline periods of record. You can see that those are outlined with the dashed green lines. We have 10 fan-on periods of record. So you can see 10 outlines in solid green for depressurization. Our reds are our fan pressures here, so we can see we're depressurizing. Our green are our envelope pressures, and then pressurization. So baseline 10 periods of record, another baseline, a baseline 10 fan-on periods of record, and second baseline for pressurization. So first, we're going to look at just we'll look at the second baseline period of record. And what I'm going to do is I'm going to click inside that period of record, and now we can see the outline goes white. And then when I do a right click, I'm going to adjust the fit time scale. So now we're just looking at the baseline period of record. And then I'm going to select just the I'm going to do a shift click, and I'm going to select just the part where the green is showing up here, so we can zoom in a little bit more on our on just our baseline periods of record. I'm going to zoom in a little bit closer, so shift click, make another box, zoom in a little closer, so we're getting all of our data points. So we can see we have quite a bit of scatter. The reason there's such a difference between the upper 2 lines and the lower 2 lines is this building was on a slope where the lower level was two floors lower than the main level. 2 of the outside references were going out the main level, the grade level on the front of the building, and 2 going out on the lower back level. So we're seeing a difference of a few pascals between levels of the floor, but then we've also got a pretty big wind variation that you can see. So if we chose just one of those, you can see how much fluctuation we'd have on our envelope pressure. But what I'm going to do next is I'm going to click on this first measurement tool. I'm going to click on that, and that brings a red line here. And at that red line, what'll be displayed is all of the pressures at that point. So our green ones are northeast, west, south, which is what we're seeing on the screen here. We can see the variance in pressures there, and we can see the average pressure. So we can see our average pressure is about 19 pascals. And as we click, I clicked on that red line, and now I'm moving it across the scale. And even though we're getting a pretty wide variation, 3 or 4 pascals difference between the lowest and highest at each of our data points, each of our lines on each side of the building, our average doesn't vary a lot. You know, we're right around 19 here. We're staying pretty close to 19, within just a couple of tenths of a pascal of 19 for most of these data points as we move across the scale. So even though we have a wide variation in pressures on each side, the average of those 4 stays pretty consistent. So we get much better data if we're averaging on 4 sides of the building. So I'm going to click off that measurement tool by clicking that on that, and then if I click Auto T and Auto Y, it'll get us back to our original screen. Auto T is the time scale, and Auto Y is the Y-axis. So when we click that, it'll include all the data on those. So that kind of is a pretty dramatic demonstration of why it's a good idea on a bigger building to average the four sides. So these are different channels on the gauges. So it requires 4 channels or 2 gauges to get these measurements, and we've labeled those as envelope pressures. So that shows that part of it. The next thing I'm going to show is the yellow here. The yellow one is 8th floor with respect to first. So that's the interior pressure. We've got all of the floors set up on what is actually the 2nd floor above grade. So that's where we've got our 4 fans set up, and we're measuring the 8th floor with respect to the first in this demonstration, with this yellow data point. So I'm gonna zoom in on. I'm gonna zoom in. I'm gonna do a click. Shift click, and we'll get that for where our fan. Well, I'll go all the way through the post baseline with that. Let me go back farther on that. So I'm going to grab that for our baseline also. For our 2 baselines. Okay, yeah, that's good. So we're showing our 2 baseline periods of record where if I click in this first baseline period of record, it's showing this yellow one at about 0.2 pascals. I'm going to click on our post baseline. Our post baseline was about 0.3, so 0.2, 0.3 for the average of that 2 minutes. And then we can see if I click in on this, this is where an induced pressure at -30. Our yellow here is at 1.6. So we were at about 0.2 to start with. We went to 1.6, so we've changed by about 1.4 when the building changed by 30. So we're within 5%. We need to be within 10%, and we're within 5%. And then if we look at, I'm going to click on our highest end here at 75. We're at induced pressure of 75 in this case, and our pressure in that space is 3.2. So again, less than 5% of our induced pressure. So we're well within that 10% standard. So even though we only have fans on 1 floor on a 10-story building, we're able to achieve good results and good data on the test. Looking at and this information would be brought into the report, and we can demonstrate that we had single zone conditions for this test. So then we'll look at our test results. I'm going to just click on our results button here. See, on the upper right, the results button will show our air tightness test results, and we can see this is a log scale, and we can see all our data points are falling pretty good along a line. So we've got, and we can tell how well all of those data points correlate by looking at our correlation coefficient. We want that to be at least 0.99, and we've got really good data here. We're at 0.999. So good data. Our exponent is 0.6, and that needs to be between 0.5 and 0.1. It typically is between 0.55 and 0.8, so our exponent looks good. And our total flow, this is our depressurization test 1, and our total flow is 16 37, and it shows us what our CFM per square foot at 75 pascals is here as a metric, and this flow is being displayed at 75. We could change the reporting pressure to other reporting pressures, but we've got it set to 75. And the Army Corps standard is 0.25, so we were well within that standard, even though this was an older building we were testing. And then we can switch from, this is a depressurization test, we can switch to test 2, and then look, we're you know, about 10% or so higher on our CFM flow, and we're at 0.24, so we're still less than 0.25. Our correlation coefficient is good again. It looks like we had one data point that was a little bit low, but we're still well within our range of a good test. And then we can also display the average, which shows those two, and then it shows our average at 17,101 for our result. So this looks like a good test. And as we're doing our test, it's a good idea to periodically check. You can, once you have a few data points, you can check on that results screen, and you'll see how well your points are fitting on that line. And if they start veering off that line, you might know that something opened up, a door opened up, or somebody opened a window, or if you were sealing some intentional opens in the building, maybe your seal broke loose. So you can check periodically to make sure your data points are lining up. Then next we'll look at an Army Corps report. So U.S. Army Corps of Engineers report, we'll click on that button, and in this page we'll enter in data that we want included. We'll tell it that we're electronically averaging our exterior pressures. We don't recommend manifolding them together. We recommend always electronically averaging those. Our operator location, sometimes people set up outside the building and do their tests from outside, but we're doing it from inside, so our computer and our gauges are inside. And we're doing both pressurization and depressurization. We chose that. And then we can enter in information about our building, information about our testing agency, our on-site personnel, and it'll pull all of that into the data report. So next, to view the report, I'm going to click up on the upper left here. See, it says report options. I'm going to click on that, and we're going to view the report. And now this is the first page. There's some general information, and we can see we've got this is the first page of 10. To toggle between pages, I'll choose the down arrow, and we can see the results of our pressurization, depressurization, and all of the other data that needs to be included in the test. Down. Our gauges and calibration date, our fans and calibration date, our other information about the building, all of our gauges and what they were labeled. So we can, you know, if you label in a way where it's easy to understand what they were, you can demonstrate that. These are our baseline pressures for depressurization, our nominal envelope pressures for that depressurization test. So all of this data that's required, and you can imagine how much time it would take to prepare all of this building for a report, is all brought into the report, including the graph. So pretty slick. So I'm going to close that preview. And then another option is to, you can export it as a rich text file, which is a nice option. I'm going to save that to the desktop, just calling it test. because what that does is you can also do it as a PDF if you're sending it out as a report, but this is that test file. It brings it into Word, so you can make all this data part of another more detailed report where you can bring in photos or infrared photos or what other narrative you want to add to a Word report. So this saves you a lot of trouble of grabbing all that data and pulling it into a report. So that's one of the great features of TECLOG3. So the next step is we'll actually show the configuration and run a TECLOG3 test. Okay, this is showing our TECLOG3 device configuration worksheet, and there's a copy of this worksheet in the help menu of TECLOG3. And we've entered the data, gathered the data from our gauges already, and entered it into this worksheet. So this is the building we're going to be demonstrating the test on, and you can see our north, south, east, and west locations are designated on the side of the building, and we've sketched out the building. We've got two zones. And we're calling them Unit A and Unit B, and we're going to set up 2 blow-at-air fans. There's no intentional openings between these 2 zones. There's only doors to the outside, so we're going to set up blow-at-air fan in each space, and we're going to call Unit A our primary zone. So we're going to be referencing our 4 envelope pressures with Unit A, and then we'll have Unit B follow Unit A. So we're going to, with the first gauge, we're going to measure, we're going to have one listed. So this is our first gauge. We're going to label it Unit A, and we've entered our serial number here in the first box, 19779, and we're calling that south. So that's our south envelope pressure, and channel B is our Unit A fan. So Unit A fan for B channel. And our second gauge, we're going to label Unit B. So that's our Unit B gauge here, and we entered the serial number of that. And on channel A, we're going to be measuring we're going to call this an interior pressure because it's not an envelope pressure. We're going to be measuring Unit B here with reference to Unit A. So we're going to maintain the same pressure in Unit B as what we're finding in Unit A. We're going to set our cruise pressure to, so we have the same induced pressure in Unit B as we have in Unit A. So we're calling that an interior pressure, and that is Unit B with reference to Unit A. And then our channel B will be a fan pressure. And then with a third gauge, we're going to label that west, and we're measuring the west envelope pressure with that gauge. And channel B will be just left turned off. And then our fourth gauge, we're going to label east, and channel A will be going to the east side, and channel B will be going to the north side. So we'll label that east and north. So that's our fan configuration, and now we'll open the TECLOG software and start doing that test. For this TECLOG3 demonstration, we're using 4 DG700 gauges. 2 of them have wired connections and 2 have Wi-Fi connections. So the first step is we'll look at our Wi-Fi networks, and we can see that one DG700 is still in the AP direct connect mode and is showing up as a network connection. And then we can see our router also, because we can only connect to one network at a time. If we're using more than one Wi-Fi device, we need all of those to connect to a router, and then we connect to the router with the computer. So I'm going to choose, I first need to connect to that DG700 that's in AP mode, and then through the TECLOG3 software, I'm launching the TECLOG3 software now. Through that software, we can set it up to router mode. So the first step is I'll go to Configuration, pull down menu, choose Settings, and we'll set up the 4 devices as DG700s. And the next step is we'll go to configure Wi-Fi settings. So click on Configure Wi-Fi Settings box over here, and it found that DG700 that's in AP mode, so I clicked on Configure Selected Devices, and our serial number shows up here. It says it's in the AP Direct Connect mode, and we want to change that to router, the router connection. So we need to enter our SSID. Enter password. Click apply and exit. And now it's reminding us that we need to connect to that router. So under our network settings, you can see our DG700 switched from AP to router mode, and then it automatically connected to our router. So now we're all set. So now we're going to scan for ports and devices. I click the Scan for Ports and Devices button there, and it's going to look for wired connections first. And our wired connection is going through an 8-port serial to USB hub. So it's finding all 8 of those COM ports are available, and the DG700 along with the serial number will show up if on those 2 that are available there. And next it's scanning for the Wi-Fi links connections, and once it finds those 2 gauges, then we're all set. So it connected with 4 Energy Conservatory devices. So now next to DG700, I'll enter the serial numbers here. So double click on the serial number, and I'll choose our first gauge, which is our unit A, DG700. I'll double click on the second one, and that's our unit B gauge. And our third one is the one we're using for A with reference to B to cruise on to follow the primary unit. And the fourth one, you can see 3 of them are grayed out now, so there's only 1 left. So we'll choose that one, and that one is on the east side of the building. So now we have the device settings set, so we'll click on View and edit the channel settings, and we'll have to configure each of the channels. And you can see there's 4 gauges along the top, the serial number of the 4 gauges, and we'll follow our configuration worksheet. And First one is the envelope pressure, and that one is on the south side. And then a Model 3 fan flow on channel B. So you notice these colors changed for the default colors for envelope pressure and fan pressure. And we'll call that our A fan. Then I'll click on the second tab here, and that's an envelope pressure west. And a Model 3 fan flow. Our B fan. And then our third tab. These are going to be two interior pressures. The first one is our B with reference to A. That we're going to be cruising off of. And the other envelope pressure, because we have it available, I'm going to use that to monitor the upper level with respect to the lower level in Unit B. I'm sure nothing's going to show up there, but I had an extra channel, so what the heck. And then the last one is our last two envelope pressures, the east side and the north side. Okay, those are all set. And then our test standard we're going to use is the Canadian General Standards Bureau. That's the test that's been in TechTite all these years. And that's a multi-point test that goes from 50 pascals down to 15 in increments of 5, so 8 points. With the pre and post baseline, we're going to speed that up a little bit and just do one baseline and just do 50, 40, 30. And the other two options are the ASTM E779, which is referenced quite a bit. That includes positive and negative pressure testing, and the European standard EN 13829 that's used for passive house testing. So we're all set here. So I'll click OK, and we're ready to start recording. And now it's going to scan for all of those connected devices. And once it finds them all, it's going to enable the communication so we can start getting data from them. Once it's done making all those connections, it'll prompt us to save it. So that's kind of a nice feature right from the beginning. It's going to start saving it, so you don't have to remember to save it at the end. And we're doing a fully guarded test, or it's also referred to as a single zone test. I'll just label that single zone. Okay, so you can see we've got our 4 envelope pressures will show up first here in green on the right side here. South, west, east, and north, followed by the 2 interior pressures that we're monitoring and using, and then the two fans, and you can see they're both marked as sealed as a default. During our baseline, we'll want those sealed. So I'm going to click on baseline period of record up here. We'll start our baseline, and we'll call that pre-base. So that will be a 2-minute period of record, and it'll take all that data for our baseline. And you'll notice each DG700 has a fan slider to control the fan and a cruise pressure that we can enter. So we can use any of those gauges, the fan control tap off of any of those to control up to 6 fans. So each DG700 could potentially control 6 fans if you wanted to set it up that way. The master control slider is going to cruise on the average of the 4 envelope pressures. So we've got in green All the green ones are our envelope pressures. It's showing envelope pressure on 4 channels. It's displaying a number and the difference between the highest and lowest number. So it looks like our fans are pretty erratic to start with, but it looks like we've only got 3 pascals difference between the highest and lowest. So that's what that number in parentheses is the difference between the highest and lowest numbers. We're only going to use 2 of these sliders. We're going to use our master slider for our primary unit, which is unit A, and then we're going to use one other one. I'm going to just delete the cruise numbers on the other ones that we're not using. The one we're using is the actually it's B to A. I labeled it A to B, but it's B with reference to A. And I'm going to put that at 0 because our primary unit is the one referencing the 4 outside pressures, and then we're going to follow that pressure to make sure that we're at the same induced pressure everywhere. So now what it's saying is remember to add 0.1, which was the average of our baseline during that period of record, to our target envelope pressure to make sure we have an induced pressure. So we've got we had quite a bit of fluctuation, but they all averaged about 0. We've got some of those are going out on the lower level and some upper level, and they kind of balance themselves out. So I'm going to, that was positive 0.1, so I'm going to go 49.9. So we have an induced pressure of 50. And then if I click in that green box in that period of record, it will show that positive 0.1 for our average envelope pressure during that period. And then it'll show our A to B was at about positive 0.4. So I'm going to put positive 0.4 in here for our target. Positive 0.4. So now we're going to cruise that, keep that pressure the same throughout the test. So we've got our we've got that all set. So the next step is we're going to, the fans are sealed now for our baseline. I'm going to click A on both of these, and then I'm going to go and unseal those 2 fans. All right, so now we're ready to start cruising. So I'm going to click on cruise, and you can see when I started that it put a line down where our cruise target is down here at -50. And you can see all of our fans are following right along there. I forgot to unlink our B to A fan from the rest of them. So the ones that are linked are going to follow that to get to 50 pascals there. So we're getting pretty close to 50, and our B to A has a little catching up to do there, so I'll help it out. So now we're coming pretty close. We're at 49.9, and our B to A is bouncing around a little bit with the wind, but we're close enough. Well, let me click on our auto Y here, and we can see how our fans are doing here. Looks like we're pretty good. So So I am going to start our fan on period of record. And we're going to call that our -50. And then after we get through that period of record, I'm going to click up. We're going to move 5 pascals. The up arrow will move at 5 towards 0, and the bottom arrow will move at 5 away from 0. So I'm going to click that one up for our next period of record. So our next target is going to be 45. Okay, that looks pretty good. I'm going to hit our next fan on period of record, and we're going to call that -45. Oh, we were going to go to 40 on that. We'll go to -35 on the next one. Then we'll be, we'll just do 3 points. So I can zoom in or out on these. So you can, just like with Google Maps, you can scroll in or out and move it back and forth. So I'm going to go 2 clicks towards 0, so we'll be cruising 35 with our next pressure. So I'll zoom in on that a little more. Okay, and then our last fan on period of record is -35. Okay, and we can look at our test results, and we're all following a line pretty good there. So I am going to turn our fans off. And it looks like we had a successful test. We ended up at about 3,900 for our total flow. During this session, we're going to demonstrate breaking out single zone results from a multi-point test in TECLOG3. So if you're testing a building that has multiple zones and you're doing a multi-point test on them, there is a way where you can break out the results of each unit based on that multi-point test, and we're going to show how to do that based on a couple of different ways the test can be done. How the process will depend on how the test was configured, and there are 2 basic ways that you can configure the test. One is if you have a number of envelope pressures, and you're going to be averaging those envelope pressures. So if you're doing, in the example we're going to use, we've got a 2-zone test where we've got 2 zones that aren't intentionally connected. There's no door between them. You can only access them from the outside, and we're cruising one primary zone to the average of those 4 envelope pressures, and then we're following it with a interior pressure that's measuring the pressure between the 2 units, and we're going to maintain the same induced pressure on both of them. And so that's one scenario. And the other scenario is more like if you're testing like townhome type units, or maybe you're testing army barracks or something where there's a number of zones that are connected together, and for each individual unit, let's say you've got an 8-unit townhouse, for each unit it has its own envelope pressures, and it's cruising on the pressure difference between that space and the outdoors. So you have 8 envelope pressures. You don't want to average those envelope pressures. You only want to use one pressure when you're doing the individual zone result. So we have to take a little different approach on how we're breaking that out. So in the first example I used, we're showing the configuration worksheet where we've got 4 gauges and 2 blower fans. Our primary zone is unit A, and all of our envelope pressures are being referenced to unit A. That's important that we do it that way. It'll speed up our test and make it easier to understand. So we've got 4 envelope pressures, one from the lower gauge, one from the left gauge, and 2 from the right gauge, which are measuring our 4 envelope pressures. It's being averaged in this unit. And unit B is at the same induced pressure, so we can still use those envelope pressures to do that calculation. And our second example is if we've got individual units that are referencing the outside. We don't want to average those pressures. If we want to know the airflow from just unit A, we're going to have to turn off the envelope pressure for unit B, otherwise the software is going to average those 2 pressures. So that's the distinction between those two. So I will pull up this test first that we did, and we'll show you how to get that information. Okay, so with this test, if I pull up the configuration settings, we can see we've got 4 gauges, and we've got 4 envelope pressures. We've got south, west, and this one is just measuring an interior pressure, and then east and north are on the 4th gauge. So the software is averaging those 4 pressures. So now it's pretty straightforward how we're going to break it out on this one. The first step is we're going to click on this region select tool, so it's the second button over, and we're going to select these 3 periods of record here. And once we've selected this, it's showing our data from that whole period of record, and we're going to first get our data for unit A. So we've got A fan and B fan, and we just want A fan to start with. So what we're going to do is we're going to seal the B fan, so we only have the fan A results. So we're going to click on sealed. So now it's just showing the flow from the total flow from that one fan. If we turned ring A back on, then it would show the result of all of them. So we're going to keep that one sealed. We're going to show the flow just from channel A. And now we're going to save this. We'll save this data file, and we'll call this unit A, and that will give us results for channel A. And then then we're going to load our original data file. Again, here's our unit A that we just saved, and we're going to go back to our single zone test, the original test we pulled up, and we're going to do that same thing again, and we're going to turn off the A fan. So we'll mark A fan as sealed, and then we're going to save our data. We're going to save this data file as unit B. So now we'll have our original test, which was called single zone, and we'll have our total results for both fans on that, and we'll have our results for unit A and unit B results separate. Okay, so that's pretty straightforward. Just select all the fan on periods of record, and then seal one of the fans. And if you've got 8 of them, then you do that same thing. You seal off 7 of them, and then you keep moving to the next one until you have them all done. So next, I'll pull up that the file. So this file, a multi-point test, guarded test with all 3 fans running at the same time, or 2 fans. We had 2 fans but 3 data points, and then we did the units individually to see the total leakage, not the leakage to the outside, but the total leakage of each unit, which would include the leakage between units. But now we want to know the multi-point results of each unit. So that first step is the same, where we'll choose that region select tool and select our data that was included in the test results. I'll select that, and we'll seal ring our unit B fan is sealed, but now we'll have to turn off our envelope pressure for B unit also, otherwise it's going to average those 2 pressures. So I'll do that by going up to configuration settings and go to view and edit channel settings, and this is our unit A pressure, and I want to go to, I clicked on the second gauge here, our unit B pressure, and we're going to change that from an envelope pressure to simply a pressure. And then we'll click OK. Okay, so now we only have, our test is only going to include 1 envelope pressure, and we have, I chose a little bit different region there, but we're sealed during that whole region, and we're going to save that. We'll call that unit A2. And then we're going to load our original data file again, which was test AB. We're going to go to configuration settings, and we're going to turn off, we're going to switch our envelope pressure to an interior pressure, or a pressure. I guess we just changed it to a pressure last time. That's probably a better option. Change that to a pressure. Then we'll use our region select tool. Region select tool. Select our period of record and change, return our, mark our unit A as sealed, and then save that. is unit B2. Okay, so that's the steps that we needed to follow to get our individual unit multi-point flows. And that concludes our webinar today. So if you have any questions, feel free to stick around, and in about 5 minutes or so we'll be taking questions. In the meantime, you can view the questions and answers that you can see during the webinar, and we'll be taking some live questions in a few minutes here.